confused. Okay, let's do another example that's a little bit more involved. So here we go. Example 2. Mr. Merrill hits a golf ball standing on a 50-foot hill. Okay, golf ball has initial velocity of 30 feet per second at an angle of 45 degrees. Okay, now they're going to ask us a bunch of questions on this. So our first question is, how long is the golf ball in the air? How long in the air? All right, so we have to remember a couple things here. Gravity is what? What is the force of gravity? You remember from your physics or science classes. Well, if you don't, we're going to say it's 32. It's actually 32.2, I think. But we're going to round to 32 feet per second squared. And we're going to use, if we're using meters, some of your questions might be in meters per second squared. It's 9.8 meters per second squared. So we're going to use those values for gravity. So write those down somewhere where they're handy. Okay, now in the air, how long is the golf ball in the air? So if we go back to our picture, this is the whole time it's in the air until we hit back down here. So the height at the beginning is basically 0, right? And then we go a long ways and we hit at 0 again, right? This problem's a little bit confusing because we're not starting at 0. We're actually starting at, yes, you got it. We're a little bit higher than 0. He's standing on a hill at 50 feet. So that's going to be our initial height, right? H sub 0. Okay. Okay, here we go. We're going to do it. So here we are. There we go. Okay. How long is it in the air? So we need an equation for the height. So we've got v sub 0, our initial velocity, times t times sine of theta. That's this equation here. You guys can't see it. There we go. Okay, this equation here. Minus 1/2 g times t squared plus h sub 0. Well, we already got h sub 0. And we know v sub 0, initial velocity is 30. And we're solving for time, right? How long? So we're solving for t. So we can't plug that in. That's what we're looking for. So 30 times t sine. They did tell us an angle, 45. Oh, nice. 45 degrees. Okay. Minus 1/2. And we're using feet per second, so we're going to use 32. And again, we're looking for t plus 50. Okay, and if we want to find the height, we want to know what t is when the height is back down at 0. Okay, so we're going to set this equal to 0. And what I would do, we can simplify this a bit. Sine of 45 is root 2 over 2, so that's 15 root 2 times t, and then that's 16 minus 16t squared plus 50. And what I would do is, this is not really factorable, right? So you're just going to use the calculator to solve this. So you're going to do, use the calculator. And your y sub 1 is equal to this here, y sub 1. and your 0 will be y sub 2. And you want to know when they're equal, so you'll do a graph intersect. On the calculator. And when you do that, you get t is equal to, well, you get two answers. You get negative 1.225 or 2.55. And you remember, can t be negative? We wish, right? We wish we could erase those wrinkles and go back in time, but we cannot. So again, time cannot be negative. So this is our answer for how long it's in the air. Okay, let's move on. Part B. What's the time to reach maximum height? So a lot of time, what we do is we say, oh, well, here we go. You know, we're standing on this 50-foot hill. Mr. Merrill hits the golf ball. It comes down at 2.55, right? Sometimes there's a tendency to go to just take 2.55 and divide it by 2. You cannot actually do that. You have to go back down to this other time. So your first time then is negative 1.225. So you've got to take the difference between the two, divide that by 2. Okay, so if we call this A and B, a little formula here, T max, and sometimes that A value is 0. If you started at 0, 0, right? A plus B divided by 2, you're just going to find that average, right, value, okay? So T max here, we do use this negative 1.225 plus 2.55, and we're going to divide that by 2, and we get 0.6625 seconds. And that's it. Okay. All right, and now we want to find that maximum height. So find maximum height. Okay, well, we've got the time where maximum height occurs, and we go back to part 1 here, part A, and we've got an equation for it as well, and we're just going to plug in that time. So y is equal to 30 times t max times sine of 45 minus 1/2 times 32 times t squared, so that's 0.6625 squared, plus that initial height of 50. Okay, and you plug that into your calculator, and you get that vector y is 57.031 feet. Okay, and then the last question, we want to know how far did Mr. Merrill hit the golf ball? So how far did the golf ball travel? So they may ask you what the range is on the homework. They mean the same thing. So this is the x distance, okay? So I'll put range in here too, just so you know. Okay, that's if they ask the range, that's the same thing, okay? How far did the golf ball travel? And I'm going to try to squeeze this on this paper. So if it's the x vector, right, then it's v sub 0 times t times cosine of theta. Well, x is equal to, well, initially we go back, that was 30 the time, we have the time is 2.55. That was in part A. So 2.55 cosine of 45. And we plug that into our calculator because we know that's root 2 over 2, right? We get 54.093 feet. So I would say that's a pretty good hit, I guess. I don't know. There we go. Maximum height. And time to reach maximum height. And how long it's in the air. Okay. All right, that's parametric equations. Thanks, guys.